Welcome to the how-to for acids, bases, and neutralization reactions. When we talk about an acid is a substance that is going to ionize in aqueous solutions to produce hydrogen ions. So these are really just a proton donor, right? Because a hydrogen ion means it's lost its electron, and really it's just made up of a proton. A monoprotic acid is when it ionizes to form only one hydrogen ion per molecule of acid. So when we look at hydrochloric acid or nitric acid, so HCl would dissociate into hydrogen ions plus chloride anions. And so in this case, we can see that it's a monoprotic acid because it produces one single hydrogen ion. However, you can have diprotic acids, and in diprotic acids, you can ionize to form two hydrogen ions per molecule of acid. And in that case, we can look at something like H2SO4, which is going to ionize into H plus and HSO4 minus. But again, this HSO4 minus can ionize again. And we see that when that hydrogen is lost and forms the sulfate anion. It actually has two hydrogen ions that it could actually produce when it ionizes. There are triprotic acids as well, which could give up 3 hydrogen ions per molecule. There's also acetic acid. And acetic acid is a weak acid. But again, this hydrogen, which is written at the end, is the one that's going to dissociate. And when it dissociates, it forms hydrogen ion and acetate anion. It is a weak acid, so it only partially ionizes. We can talk about bases as well. Bases are substances that accept hydrogen ions. And when they do, they actually produce hydroxide ions when they're dissolved in water. So a lot of examples include things like sodium hydroxide, which would form sodium ions, and hydroxide anions. Potassium hydroxide, calcium hydroxide, and there's ammonia. Ammonia is a weak base. And when it reacts with water, it actually forms ammonium, which is NH4+, and it produces hydroxide ions. This is one that you just have to memorize. It is the only weak base I require you to memorize. So really, we need to understand that strong acids and strong bases are strong electrolytes. Weak acids and weak bases are weak electrolytes, and this goes back to the how-to video on identifying electrolytes. There's a list of common strong acids and strong bases. You do need to memorize these. You need to know these in order to identify whether you have strong electrolytes or weak electrolytes. When we identify strong and weak electrolytes, going back to that same video, we use our table. And if you don't remember this, please go back and watch the how-to video for identifying electrolytes. We also need to understand that we have strong acid ionization and weak acid ionization. Strong acid ionization has a single arrow going in one direction. This means that it ionizes completely. Whereas for a weak electrolyte, we write this double arrow going in both directions because here we only ionize partially. A neutralization reaction is a mixture of an acid with a base. And in that, a neutralization reaction occurs when we have some kind of acid reacting with a base. And in this case, it's really just a double displacement reaction. Because what we really have is the sodium ion is going to react with the chloride ion, and the hydroxide is going to react with this hydrogen, forming water and a salt, which is sodium chloride. We could write out the ionic equation for that, and then ultimately solve for the net ionic equation. If you notice, hydrochloric acid is a strong acid, sodium hydroxide is a strong base, and anytime we mix a strong acid plus a strong base, we always get this same net ionic equation. So a neutralization reaction is just another type of double displacement reaction. There are a couple exceptions to this rule, where sulfides can react with an acid to form gases. So here we have hydrochloric acid plus sodium sulfide. Again, the hydrogen can react with the sulfur, sodium with chloride, and we get sodium chloride and H2S. This really isn't that different than if this was an oxygen instead of the sulfur. Another exception to the rule is carbonate ions react with acid to produce a salt, carbon dioxide, and water. So anytime you see some kind of carbonate salt, we know that that's going to react with an acid, and in that case, it's always going to produce carbon dioxide as a gas, it's going to form water as a liquid, and then it's going to form a salt with what's left over. Well, what's left over is calcium and chloride. This concludes how to for acids, bases, and neutralization reactions.